To understand the next set of questions or the concept, we need to understand a word called as homogeneous function. When does the function become homogeneous? To be homogeneous, it has to pass through the following test. The test being, if I happen to substitute lambda x comma lambda y in place of x and y, where lambda is a constant, if you are able to rewrite the given expression as lambda times of n, where n belongs to an integer, f of x comma y. This is a homogeneous function. I'll give an example. If you have f of x comma y, y square plus 2xy, then f of lambda x comma lambda y will look like lambda y the whole square plus 2 into lambda x into lambda y. So basically this is lambda square y square plus 2 into or lambda square into 2xy. So there is basically lambda square that is common, and we have y square plus 2xy. But what is y square plus 2xy? That's nothing but your initial expression. And so this is said to be a homogeneous function. So basically the funda over here is that if you have some kind of substitution, some constant lambda over here, the same constant by the way, being substituted in place of x and y, so lambda x and lambda y, that's what we're going to substitute. And if we rearrange and we get this particular conclusion, that is it's lambda to the power of n f of x comma y, then this function is said to be a homogeneous function of degree n. And over here, this is a homogeneous function of degree 2, because there is a 2 over here. Okay, it always has to be an integer, right? Now let me show an example to concrete the idea. So we have some kind of function. I'm going to substitute some constant. It can be any constant. I'm calling that as m. So this would be 3 times of mx by 4my plus 10. Can I do something with this? I can't. I can't further rewrite this as m to the power of n f of x comma y. So this is not a homogeneous function. Next, over here, if I happen to substitute theta x, theta y, again theta over here is a constant. So 3 theta x divided by 4 theta y minus 4 theta x. And we have theta in the numerator, 3x, theta in the denominator, 4y minus 4x. So theta will get cancelled, and we have, this is f of x comma y, is it not? And I can write theta as theta to the power of 0, because that is 1. Anything to the power of 0 is 1. And this is what? This is a homogeneous function, yes. Of what degree? Of degree 0. Okay, why? Because theta is raised to the power of 0. As simple as that. In the very first example, we saw that it is raised to the power of 2. The constant is raised to the power of 2. And so it's of degree 2. Okay, so this is the entire funda. Pause and have a look. And do copy, of course. Oh yeah, by the way, I forgot to mention, we're going to solve homogeneous function of degree 0. Actually, homogeneous differential equation of degree 0. That's what we're going to solve. Okay, okay, copy this as well.